Yes. Okay. Sorry, I'm laughing. Welcome to episode 120. What's new at Mutiny? Which I think is the first one where we talk about stuff happening Quarkus 3, I think. Yeah, just a few highlights here. There are rumors that some people have received a T-shirt. How many here have received a T-shirt? Holly?
It's on its way.
All right. Yeah, I have seen some traces. Okay. So anyway, the T-shirt is ahead of time. So as Clement just said a few minutes before we joined, we have an async event, a reactive event going on here. So we are actually, if you have received a Quarkus 3 T-shirt, that's not because Quarkus 3 is released yet. It's because we wanted this T-shirts to be there once the GA is out, rather than in the past where we have the GA out and then the T-shirt arrives 12 months later. So
when the next GA was out. When we were working on the next major version.
So anyway, all good. So
it turns out synchronization is a hard problem.
Yes, it's tricky. Yeah. And on that, I'm actually this morning I'm writing on the Alpha 5 release blog, which the big thing here is that Hibernate 6 is included, which will cause all kind of fun. So for those, Quarkus 3 is the move to Jakarta and what other things we can take that is related. One is Hibernate 6. We will have a blog insights about that in the future, but that I'll say here what it is. Like in Alpha 5, we have Hibernate 6. The Hibernate reactive will have some issues because there are a lot of things changes. The reason why we do these alphas is to kind of get all these things integrated, and one of them is Hibernate reactive. And then another one is the Mutiny changes that we will talk about here. So anyway, hopefully today, mid Wednesday, we will have a blog and an Alpha 5 out. The artifacts are available. They're not available yet, but we'll have the build and have the release out this week. So anyway, maybe we should introduce ourselves. I tend to get the feedback that I forget to introduce people. So
it's a very asynchronous episode where things are not in order, but it's fine.
That's fine. Yeah. So anyway, Holly, go ahead.
Yeah. So I'm Holly. I'm one of the Quarkus engineers.
Oh, we can even keep it short or sweet. Julien, who are you?
Hey, welcome everyone. So I'm Julien. I'm working on things like Mutiny a lot, and integration in Quarkus, and also a bit of Vertex, because I wrote a book which I recommend, which is called Vertex in Action, which is great. And that's it.
And okay, so I'm Clement. I'm also working on Quarkus. I created Mutiny over summer a few years ago, and now I'm doing plenty of things around Quarkus, especially around the reactive side of Quarkus. And I wrote another amazing book, which is Reactive Systems in Java, which was covering Quarkus 2. It was just released at the same time as Quarkus 2, more or less. And we had a question in the chat if there will be Quarkus 3 updates. Well, under discussion at the moment. You need to understand that writing a book is more or less a no-life for 1 year, if not more. So it's discussion with your publisher, but also a discussion with your family. I won't say which one is the hardest.
Oh yeah, you got rabbits since you had this book, right? So that's another thing.
Sorry?
Didn't you get rabbits since you wrote the book? You also got the rabbits.
I switched rabbit. Now I have 2 rabbits. Before I had only 1, but yeah.
Okay, yeah, life is harder. That's why. Okay. Yeah, and anyway, Julie just says that Clement has the best book. So you have to.
So I think I have to leave this stream, right?
Yeah, and there is of course Enterprise OSGI in action. Nobody's mentioned that in the stream yet.
Yeah, that's a nice one. The OSGI in action was written by my PhD advisor, so you did the enterprise version of that one. That's funny. Long time. Well, maybe let's start about what's new in Mutiny. So with the Quarkus 3, we are integrating Mutiny 2.0. So don't expect a lot of big change in terms of API. It's mostly something we were thinking about a long time. So the first thing is that we have a lot of deprecated methods and API iteration and things like that. So first thing, big cleanup. We removed all those deprecated methods that was long overdue, but we keep them for several years. So now it's time to remove them. And the second one, it's really an internal change, but we believe that in 2023, it's time to switch from the legacy Reactive Streams API to the Java Flow API, because it's part of the JDK. It's released with the JDK. It's a module, and there are more and more classes and APIs using that, including in the JDK, but not only. And that's one of the other things we did, is to switch to Flow. Obviously, we provide an adapter if you are still using Reactive Streams. If you are using Mutiny directly, you won't see any change, so it's completely backward compatible. If you integrate with other Reactive APIs, you need to be aware of that maybe you will see class cast exception or something like that. And in that case, you will need to use the adapters that will just wrap it as a flow. The funny thing is that Reactive Streams and Flow are exactly the same APIs. There is absolutely no difference. The only difference is a package name, which remind me about Jakarta. But yeah, it was before the Jakarta Cine. It's like, hey, let's do a test and see how it goes.
Make it good. Is my audio still bad, or?
Yeah, it's still crackling. It's a little bit,
right, I'll be quiet until I figure out what's going
on. Maybe, Julien, you can share a few things, a few slides. I don't know what you prepared. It's a very reactive session where we don't really know where we're going, so everything is fine.
So don't worry, but eventually it will be fine. So what I'm going to do is I'm going to share my my screen. I have some Keynote slides because I love Keynote, other things. But I'm not going to put it in full screen because the other screen is not going to work. So yeah, sorry, I will keep it this way. So I think, yeah, before we talk about... Yeah?
Don't see anything right now. So if you are
don't
sharing...
see anything. Oh,
yeah, now we see it. Yeah.
You know why? Because I had to click on the screen. Like, you say share the screen, so it's fine, but then you have to actually click on it for it to work. Okay, so you see my screen, which is not too bad, I think. So I think, yeah, before we talk about, Reactive Stream versus Flow, I think it's good to step back a little bit and think about what kind of streams are we talking about, and what are the properties of the streams, etc. So if you look into the modern JDK, what you have is two classes of streams, actually. The first one is in Java util stream. I think people know, like, you have a collection, you do that stream, and once you have that stream, you can do things like map, flat map, filter. You can use split iterators if you want. So you have that really nice set of interfaces and objects if you want to do some in-memory processing, like you have a stream of data in memory, or maybe also infinite sequences. But basically, yeah, you do some CPU processing. You have some nice features if you want to do parallel processing, etc. So these are the JDK collection stream that most people know. But then there are the other streams in the JDK that fewer people actually know, which is the APIs coming from the Reactive Stream specification, and which are now in the JDK since Java 9. Whoops. So Holly is telling me I should do something like play in window. That's great. Okay, thank you, Holly. Yeah, I just need to move that.
Yeah, no, I can see your whole screen.
Okay, so as we say in French, when I go to bed, I will be less stupid. I've learned a new trick today. So yeah, these are the streams. So these streams are different because these streams are for processing streams of asynchronous I/O events. So it's a bit different. And it's so you have, on one hand, you have the in-memory streams, from collections. On the other hand, you have these streams for async IO and data processing. And they are back pressured, and we will see what it means in a minute. But basically, yeah, it's in the JDK since Java 9, and it's the previous what I call the legacy Reactive Streams API come from a long time ago, and they are still compiled to Java 6. So basically, in your projects, I don't think today you use Java 6. So same thing, just move over to something a little more modern. That's way better. So if you don't know what's reactive streams, I think a good analogy is to have a set of have that kind of chain where you put apples, because most people love apples. So you have apples, flowering on a chain, and imagine you want to put them in buckets. Like you have operators along the stream, and you want to put apples in buckets because then you want to ship them into retail, etc. So this is a stream of apples, and you can have some transformation, like you can have people, looking for rotten apples and removing apples from the streams because they are bad apples, or maybe they are too young or something. But you can do some transformation on the apples. You could have a transformation which is more involving, which is to make an apple pie, but that's a bit different. So yeah, basically you have a stream of apples, and okay, so it doesn't sound like it's just a stream, right? But the thing is, it has to be back pressured, and back pressured means that you want to ensure that you have some kind of control flow mechanism. And what I mean by that is, so imagine you are the operator at the end of the string, and you have to take the apples and put them in the buckets. Your buckets, they have finite size. Like in a given bucket, I can put, say, 50 apples, something like this. So if the stream just keeps on sending you apples, at some point you don't have enough buckets, and basically you're going to have lots of apples on your feet and everywhere. And it's not going to be very great. So you need a way as the downstream consumer to tell the stream what's your capacity, how many apples you will be able to deal with. So that's what we call back pressure. It's a way to tell the stream what's your capacity and how much apples you can keep up with, etc. So that's Holly.
I was just going to say, it's the bit that was missing in the Sorcerer's Apprentice, when they just keep coming and coming and coming, and there's no mechanism to say, please stop sending them to me. But I'm just enjoying the video as well of, like, the little operator at the end as more and more apples come, and he's getting sort of submerged in apples and, desperately trying to climb to the top of the pile of apples. And then it's like the horror movie scenario. Yeah.
So this is why we have, reactive streams. And it's not a very complex protocol, actually. The control flow is kind of like TCP, sorry. So you basically say, at some point I have a capacity of 20, then I have 30, and this, capacity and demand is going to accumulate, and the stream is going to send you at most, your capacity, your current capacity. So you shouldn't be, overwhelmed with tons of apples coming at you. And the idea of reactive streams is that it's an API plus a protocol, and it's implemented by asynchronous components on the JVM. So basically, the idea is that you can take an ACA stream, which is written in Scala, have a bit of processing in Irish Java, and then you can receive it, and process it on Mutiny. And because all these libraries and frameworks talk the reactive streams protocol, they should be able, to work with each other and have, processing which is correct, because you're not going to overflow and do something stupid. So that's the idea of reactive streams. Now, the thing. So if we put things in place, so you had these two flavors of APIs, if you will, like the reactive streams legacy API, which is Java 6 based, which you can find it, in the wild, but it's really legacy. And now you have the same APIs, but in the JDK. So switching from one to the other is not super complex, because these are the same name. Like you have a publisher, then you have a floated publisher. So really the same semantics. It's a very direct mapping between the two API sets. but it's not the thing that you should be using actually in your code. In your code, what you should be using is a higher level user-facing library. Like you should be using something like Mutiny or Heroic Java or something that's giving you operators, so way to transform the apples or filter the apples, the ordered apples, etc. And in the middle, so you had the static interface, which are the APIs, but you had the dynamic interface, which is the protocol. And the protocol is the heart piece of Reactive Streams, because when you look at Reactive Streams, it doesn't sound too complex to work with. Like it's only 4 interfaces, but then you have a protocol and a TCK, which is very strict and which is enforcing tons of rules, like the threading model, things you need to do, etc. So just to show you this again, if you don't know what we're talking about, on the right-hand side you have Mutiny. So it's the API that you're using in Quarkus whenever you do reactive. And on the left-hand side we have the more classic Heroic Java /Reactor, but that's kind of the same code base initially. So on one hand you have something which is more functional, monadic. So you have to know you need to know your way around functional programming idioms and monads and all that stuff whenever you want to compose asynchronous operations. Whereas in Mutiny we have something which is a bit more verbose but more friendly and event-based. It's a dialect which is event-based. So it's something that you don't have to have a PhD in functional programming. When you come back in 6 months, you should be able to understand things like you have select where, on item do this, do that. So it's something that our users tend to actually enjoy because it makes reactive programming a little more accessible, I should say. So okay, if you rerun and get back to Reactive Streams, so it's only 4 interfaces and actually 3 because one is a mix of 2 interfaces. So we have a publisher. A publisher is publishing, giving you events, giving you data. A subscriber is something that's at the other end, which is telling a stream, hey, give me some elements. I'd like to consume elements. A subscription is what the subscriber will be given to control the flow, to say, I want to cancel, or I want to get up to 100 elements, or something like this. And the processor is the kind of extra interface that both a subscriber and a publisher. So it's really done to transform items in the middle or something like this. So on the surface it looks pretty simple. I have a bunch of diagrams to show what's the protocol like. So as a subscriber, when you want to connect to a stream, you say, hey, subscribe me. So you call a subscribe method with basically a reference to yourself. So you would be able to be subscribed. And then all the chain is going to be notified that you have a new subscription request. And then once you had that, basically the stream is going to send you events. Like you have on next to send you an event. You have an complete whenever the stream has finished. So you can receive events like this. The control flow is done using the request method and subscription. So you say, give me up to 10 elements, and then you have the guarantee that the publisher will not give you more than 10 items eventually, etc., etc. So it's a very simple asynchronous stream protocol when you look at it. There's also a message, an event for failures. So I don't know if you have a broken pipe or the database, the TCP connection is broken or something, then you have a terminal event, which is a failure to tell you that the stream has failed and that you should stop or you should retry to submit or something. And yeah, that's the protocol. And you may also be able to cancel at some point. Like as a subscriber, if I don't want to receive further elements at some point, I just say cancel. I cancel my subscription, and then eventually I will stop receiving events because the stream will stop. So it doesn't have to be synchronous and immediate, but eventually, very shortly, I should not receive further elements. So yeah, it's so simple that you could think, well, I'm going to make a publisher by myself. What could go wrong? It shouldn't be that complicated. It's only 4 interfaces, right? It should be very simple. So do you want me to show you how to make a publisher?
Yeah. Go ahead.
That was
It looks easy.
Yeah.
Is my sound better now, by the way?
Sorry, what did you say, Max?
Is my sound? Was that a no?
I think it is.
Well, yeah. The thing is, if you said no, then I would have been very embarrassed because I had my IntelliJ ready to go. So just for the drama that I was, building the tension, So if you want to build a publisher, okay, you have an interface which is called a flow publisher. Like I want to publish a flow of string elements. And there's only one method that I have to implement, which is called subscribe. And subscribe takes a subscriber. So, they had these fancy wildcards with covariance and contravariance, but that's another thing. And you have to subscribe, right? So the publisher that I would like to try to do, but you will quickly see that we will reach a state where it doesn't work. But I just want to say I have a string of up to max elements, which is an upper bound in the number of elements. And, that's what I would like to do. And I would just like to publish, I don't know, random numbers, perhaps. I think it's fairly easy to understand. So once you have that subscriber method, which is being called, you need to send the subscriber a subscription. So subscription is also something that's coming from the Reactive Stream interface. So if I want a subscription, I can do something like this. I have a class. I implement flow.subscription, and flow.subscription comes with basically 2 methods that I have to implement. So one is request, and request is basically where the subscriber is going to ask for elements, and cancel to say, well, I'm fed up with the stream. I don't want to receive anything anymore. So whoops. Okay. So what should I do? Well, I have a bit of boilerplate in place already. So I have a random number publisher. I have a long to keep track of how many items I've sent. So then once I reach the max, I can just stop and complete the stream. So, let's just do some very naive implementation. So the only one who can't ask any question is Clement, because obviously he knows. So he shouldn't do anything.
I implemented that class a few times already.
Yeah, that's the thing you have to do in your life. Once in your life, you need to make a publisher. Okay, so I'm not going to deal with cancel right now because, just it's like, transactions or security, people don't do it. So let's just imagine that I have a request coming and somebody's asking me elements. So I will go with the most naive fashion. I will do something like for each element, up to n elements that have been requested, I would just, directly generate my numbers. And I have a reference, of course, to my subscriber, so I can just forward some events. So what I can do random next, I don't know, next int. I would just take an int. So that's my number. And then I can do something like subscriber. But so you see all the events you have on complete when it's done, on error if you have anything which is stupid, or on next if you want to forward a value. So I'm going to send something like this plus the number plus this. I'm also going to do something like send counter equals send counter plus 1. Actually, it's a long, so I would just do it like this. And last thing is if send counter is more than max elements, what I'm going to do is complete the stream on complete, and return. And how does it sound? So it sounds like a good stream. You know, you ask for, say, 50 elements. I'm going to send you 50 elements. I'm pretty sure Clement already knows what's wrong. There are a few things, but we'll come back to it. So if I want to check, I can also, you know, have a main method here. Like I have my publisher, and I say I want up to 20 elements, and I'm going to subscribe to that stream. So when you subscribe, you need to pass a subscriber, and a subscriber has these 4 methods. So it's basically callbacks when you have the subscription, callbacks you have whenever you have an element, a callback when you have an error, and a callback when you complete. And what I'm going to do is, at the time that I'm being subscribed, I'm going to ask for the maximum number of elements. So long.max value in Reactive Streams, it means that it's an unbounded stream. Like you tell the publisher, just give me anything you have, and I will take it. We could do other things like requesting like 10 elements. We could keep the subscription in a thread pool executor to periodically request elements, like every 5 seconds to request 10 elements. So there are lots of interesting things you could be doing. But if I run this method, I'm very happy because I have my 20 random numbers. You know, it looks like it's a good Reactive stream. So now what I'm going to do, and you can see that I love doing hello worlds. Actually, my whole career is based on doing hello worlds. So we have something which is called the Reactive Streams TCK, which is used to check if your publisher, your subscribers, you know, if they are correct with regards to the Reactive Streams specification. So if you want to pass your publisher to the TCK, what you have to do is, so first thing you need to like testng, because it's written in testng, but that's not a big deal because you can run testng in Unit 5 if you want to, so that's not really a blocker. You have to use a base class which is called Flow Publisher Verification, which is going to run all the checks for you. And basically you need to create a publisher. Like I'm going to give it a publisher with the maximum number of elements. That's actually a weird thing in the TCK. So all the people who've been using the Reactive Stream TCK know that it's a bit annoying sometimes to have that max number of elements when you write things and you don't know in advance how many items you have. It might be a bit funky. And if your stream has failures or failure modes, you might also pass a failed publisher or null if you don't have that. So now it's the time of truth. I'm going to run the TCK test, and I will see that my publisher is actually a bit broken. So you have all these rules, like it's going to, you know, try to validate a bunch of things, and I have 11 failures, which is not too bad. And if you, so I can't zoom, I think, yeah, it doesn't work. But basically, if you look at all the errors, you will see that, you know, it's not correctly implementing the protocol because it doesn't support things like multiple requests, concurrent requests. It doesn't support cancellation. It doesn't support lots of things. So I'm not going to actually go and fix it, but I will show you something which is a bit more correct, and I'll show you some a famous pattern that Clement loves, which is called the drain loop. But basically, yeah, the issue here is that you can have Siri. Yeah, it's my voice assistant. Sorry, somehow it thought I was talking to it. Stupid Siri. Anyway, so the request and cancel methods, they are in the subscription, and basically the subscriber can do some concurrent requests, multiple threads, but you need to enforce certain rules in your Reactive Streams, like the items must be serialized on one thread. So you have multiple threads, it has to be on one thread at some point. You can have multiple threads sending you events. So you have lots of rules that you have to implement if you want to do things correctly. Yeah.
And one thing, the TCK does not check everything. So you need to take the rules and check them one by one. The TCK is only doing 50% of the work. The other 50%, there is no automatic test, and you need to either implement those tests or at least make sure that it passes.
There are some gray areas in the TCK. So
yeah,
there are
also,
the unwritten rules, but there are also some things that are a bit weird because they could be checked, but they are not being checked. It's a bit suspicious.
So I just want to make sure we're not like what you're showing here is all the complexities of implementing your own stream, right? So
yeah,
not what users would normally do. It's just
no regular users will ever do that, and that's actually the thing we want to explain here, is that don't even try. It's or you are going to have very long nights, very long nights.
I hear you might have had some of those, but yes, okay.
Yeah, I'm still recovering.
Clement suffered so that the rest of us don't have to.
Well, actually, it's not only me. As people having implemented Eric Java or reactors also had to deal with all those rules and come with this drain loop patterns which precede reactive programming. But it's something we have to use in that case because everything can happen at the same time, concurrently, and you need to serialize all those events in the right order. If you don't do that, then the application code using your streams is going to just be completely broken. Yeah, and I forgot to wear my cape today, Antonio, but in Paris.
And actually, I think, so what I'm going to show you here, and then we'll switch to the next consideration is, it's quite simple compared to the horror stories you can have with flat maps implementations. Like when you have an operation and you want to delegate to another asynchronous operation and then compose the results in a stream, it's horrific because you have inner drain loops and I think it's really what wakes up Clement at night sometimes. Because when you look at the code,
I'm still thinking that there are bugs in my double inner loops mechanism, but no one has found them right now. So
or they don't know. They just know. So if you really want to do that kind of correct way to request elements, so the thing you need to check is first thing you need to check. I have been canceled. Like if you've been canceled, you shouldn't do anything. Then you have to check if the number is positive, because obviously we're on Java, so we have signed integers. So you need to check, and if someone is asking you -10 elements, you need to tell that subscriber that is not the thing to do. And then you need to accumulate the demand in some kind of atomic long value, which is holding the current demand, which is in progress. How many requests have been received, and then you go to the famous drain loop. So the drain loop, it's basically the thing that's going to ensure that you have only one thread at a given point in time, which is sending events to the subscriber. So if you have multiple threads doing requests, only one of these threads should be the one sending events to make sure that you have serialization in your stream. So the first thing to do is you have some kind of atomic integer to say, are there other threads running? So it's a very cheap way to have a kind of semaphore, if you will, just to say, okay, if others are working, I'm just going to exit because someone else is going to do the hard work for me. And then you look at what's the current demand. You keep track of if that, and you enter the loop and you say, until I've fulfilled the whole demand, I'm going to generate some values. If it's null, it's not correct and I should complete. If it, then you send next. And then you look at the demand. So you subtract all the items that you have emitted from the current demand that might have changed, because meanwhile someone might have requested further elements. And then you check, if nobody else is, if there's no work in progress anymore, you can just exit, etc., etc.
One thing, you can imagine all the nice code analysis, static analysis rules, and so on, when they see that kind of code, they're just, yeah, everything is red. But actually, it's almost the only way to do it properly.
Yeah, so if you're using some kind of static analysis service in the cloud, just make sure you don't configure it with the enterprise settings, enterprise application settings, because it's going to scream all the time. It's going to scream because you have a volatile at some point.
Yeah, the while true is problematic. Yeah, everything is problematic.
They don't like it. So yeah. So the idea was not to show us as superheroes of implementing reactive streams, but just so people understand that it's 4 interfaces, but the protocol is really hard to respect and make sure they have components that work correctly.
To be clear, I received reproducers where people have tried to implement publishers and open an issue because something is broken, and yeah, most of the time it's not the Quarkus side.
So it can be indeed very, very funny. So yeah, if you feel like doing it, think twice. It can be fun, but make sure you know what you're doing. So back to the problem we had. So in Quarkus, and basically, in Mutiny, so the foundation we are using now is not the legacy Reactive Streams API anymore, but flow from the JDK. And then it has, of course, an impact on the code bases that would be using Reactive Streams /Mutiny /whatever. So there are basically 3 ways to tackle the problem. The most simple one is to just migrate from legacy APIs to Flow. It's the same APIs, but with a different name, like you have flow.something, and it's a different package. So it's not terribly hard to migrate. And then you can always check because it's still the same TCK. So the nice thing is that the Reactive Stream TCK, although it's a bit old, it was still considered at a time where people knew that you would have at some point a migration to Flow. So you have one variant which is using the legacy APIs, and another variant of the TCK which is using the newer Flow APIs. So in any case, different APIs, but it's new APIs, but the same TCK. So it's still proper Reactive Streams. In some cases, you might not be able to migrate because you are using some library which is still stuck to using Reactive Streams APIs. So in this case, and they haven't migrated, you need to use adapters. That's a very simple strategy. And I will show you the kind of adapters you can use from MutinyZero. Basically, you can just use these tiny adapters, and they have virtually no cost because the JIT compiler will be more than happy to just eliminate one level of interaction, which is very straightforward. And the other way of supporting the migration is to do what we did in certain parts in Quarkus, like in REST Reactive or Reactive Messaging. We are supporting both APIs because we want to make sure that existing code bases will have a chance to migrate. So we have a transition period to help people migrate from the old world to the new world. So in these projects, you can still use the 2 APIs if you want to. Although, as a user, you should not be touching Publisher directly or exposing Publisher directly. You should be using Mutiny or something else if you like. But we will support both options. So we have another library which is called MutinyZero because initially we wanted to make sure that we had the bottlenecks to help people create Reactive Streams compliant publishers, but that would be correct. Because as you saw, it's very easy to do something that doesn't work. So we had the MutinyZero core library, which is giving you tools to create your own publishers. So if you have some networking code, you can easily blend it to make streams, Reactive Streams. If it's using Vertex as the networking library, there's even a direct converter from Vertex Streams to publishers, which is great. And there's also a library with a no-cost adapters between the 2 APIs. So I can show you that very quickly. So if you want to make your own publisher, you have something which is called Zero Publisher, which is coming from MutinyZero, and you can create a publisher with something that I call a tube, and you can basically react to events like when requested. So when somebody is requesting new elements, you can respond. When you're being canceled, you can do something. And we do the hard work for you, like in the send method you see here. This one is thread safe, and it's going to do the serialization work for you underneath. So whenever using these methods, you should create a publisher that's correct. That's the promise of MutinyZero.
So is the story kind of from Mutiny Zero to Mutiny Hero?
Yeah.
Actually, we started with Mutiny itself, and then we looked at a lot of mostly database drivers that have been implemented publishers and how they were actually implemented. And there is some horror stories in that landscape, a lot. And most of the time, it was, hey, we have completion stage underneath, and let's expose them as a publisher. And we were like, why will you do that? Because on a completion stage, back pressure doesn't make any sense. Sometimes they have some bad Genie and they try to do a stream and so on, but they actually don't pass the TCK, or roughly, like with some very open interpretation of the TCK and of the rules. And yeah, we wanted something to help people to actually implement publishers if they really have to. But again, as end users, you will never use that. That is things underneath that if you're an integrator or a database driver or something like that, you should use this. It's very small. I think we had the size is 44 kilobytes, something like that.
It used to be like this. So yeah, it's very small. But it's true that the horror stories we saw with Clement is that lots of drivers, they are using things that don't stream. So they load stuff possibly asynchronously in memory, but then they say, hey, it's a stream, but it's not a stream. So sometimes it's a bit, funky. So yeah, again, that MutinyZero library, as Clement said, is something you should be using if you are, if you want to expose a publisher to the world, to other frameworks and libraries, but you don't want to enforce that using one particular library, like a full stack. Like you could say, I want to use the full-blown Mutiny, but it's a bit too much because you're dragging lots of operators on things people may not want in your stack. So MutinyZero is really focused about doing just the publisher bits, and that's it. So this is why we call it zero, because it's like the same, but without the trigger. And if you want to do the adaptation,
I just got that one. Okay.
Yeah. So sometimes I have some very stupid comparisons. And if you want to use the Nocos adapters, that's another module in MutinyZero. But let's say, so if you know reactive programming, you might know Flowable, which is coming from AVX Java 3. So I can create, Flowable like this, and it's a legacy publisher. Like I can cast it as a publisher because it is what it is. And if I want to turn that publisher into a Flow publisher, I can use the MutinyZero adapters. So I can adapt, the publisher, the subscriber, the processor, anything in between. And then I get a modern publisher, and I can just say consume it, for example, in Mutiny as a publisher itself, because Mutiny wants Flow publishers now, not legacy publishers anymore.
We may explain the safe publisher. That we had so many horror story with not really true publisher that now we say we had to enforce a lot of checks in Mutiny. While here we say, okay, it's correct, and we will just bypass all the tests, all the checks.
Yeah. So when you say create from, let me show you publisher like this. Yeah, basically you have two ways. So publisher is going to assume that the publisher might not fully respect the Reactive Streams protocol. So there are things in place to check and force serialization and do some stuff. So it's an extra layer of indirection, if you will, just to make sure the protocol is fully respected. And safe publisher, if you know that that's a properly tested, TCK valid publisher component, you can just say integrate it and we won't do all these extra checks that may burn a few CPU cycles. That's the idea. So that's really it for Mutiny Zero. So you can expose publishers, you can adapt, and you can also create publishers. If you know Vertex, you have a very simple way to make streams. And that's basically all I got.
So another thing about Vertex, we also generate the API, the full Vertex API using Mutiny, not MutinyZero, but using Mutiny. This we already published a few versions using Mutiny 2, so you can already, if you are a Vertex user, you can actually already use Mutiny 2 flows with the Vertex API.
So just for me to summarize here, so the MutinyZero is something we recommend people that are writing other frameworks, like
clients, networking, database drivers, and things like that. Yes.
So that when the different flow, like, because we have like, how many flow implementations are there in? Oh, sorry, Reactive. Are there?
There is 4 modules, one in the Java world.
Yeah, right. So there's like, and the problem is that if you pick one, then you're kind of locked into either Quarkus or to Spring or something else. And with this, we have a way to coexist, so to speak.
Yeah.
Yeah. Very cool.
There is a few things that Julien didn't mention about what's next for Mutiny. So there is a few things that we want to do in the 2.x branch. So in the next few months, maybe years, we don't know. One of the big use cases for Mutiny is data streaming. So when you have data streams that you need to process and things like that. And there is a few operators that start to be that will need to be implemented directly in Mutiny to avoid people to do very funky things, typically grouping elements by sessions, if you will. So you have one session, and after a period of inactivity, you say, okay, that's the end of the session, and I get another session when I start having another thing. So that's the kind of patterns we're looking. This is all driven by this data streaming new landscapes, which is emerging right now. Obviously, you may have heard about Loom. Loom is not going to kill Mutiny. Actually, it will make Mutiny really much better for data streams, because Loom and data streams doesn't really work very well. For unary operation, like uni in Mutiny, yes, but for the streams, it's kind of tricky. There is no back pressure cancellation. There is plenty of things that are missing. But for unary operation, Looms is very nice. It's already there. We are continuing integrating Loom in Quarkus. There is already an integration, but we want to go the next step, the next mile. And it's tricky because we realize that, there is big performance hogs when you start using Loom. Thread locals is a big one. Typically, a lot of thread locals have been used for pooling. So to have only a set of resources, except that when you have virtual threads, that doesn't work at all. And because virtual thread locals are allocated, you get your memory filled with that. And so there's plenty of things. And we have Francesco, which is looking into that and try to patch a lot of libraries, including Netty. There is discussion with Jackson and so on. It's coming, but we will have a few years before Loom is completely ready for prime time. I know that a lot of people will be disappointed by that statement, but I think that's just the truth. That you will have to wait for a few years. Francisco saying so much fun. We have different kind of fun, but
and that's why we're lucky to have Francisco on the team.
Because it's generally looking at flame graph and things like that. So in between, we're working on how to improve the integration between both worlds, so how our reactive APIs works in Loom environment. We already have everything, but there is still things where rough angles and rough things that we can polish and improve.
Sorry, I don't remember. So in Quarkus 3, so just to talk about like how much this affects Quarkus users. For 2.3, there's the API is more or less the same. It's just that the package names has changed.
Yeah,
right?
But as a user, you shouldn't see any impact as a user.
If you're using Mutiny, there is absolutely no difference. It's underneath that there is a change, but that's it. If you're an integrator, then yes, you will see the change. That's why we explain a little bit things.
So do we actually? So for those who don't know, so in Quarkus 3 we have the migration. I don't like call migration tool, but update tool. We use OmniWrite to move things over. Do you know if the flow thing has been included there?
No, it has not been included, and actually it's almost on purpose until now, so we can catch or actually identify the users that are actually integrating, and so we can actually discuss and see, well, make sure that they are doing the proper thing. When it will be close to GA, we probably should add the rules because we don't really want to discuss with everyone integrating, just early adopter. Yes, we want to see what they are doing and so on. But again, if you're using plain Mutiny, no chance for you. Except if you are using deprecated methods that have been deprecated for 1 or 2 years, then yes, okay, that won't compile. But yeah, you had a warning for 2 years.
Well, in Java, they have warning for like 20 years.
Yes, with the stop. But I want to keep it actually. So
yeah. Okay, so overall, for let's say normal Quarkus users, the move to flow should not affect people. But if you're writing extensions and doing some other more deeper dive stuff, there will be. And then we tell people that are writing integrations and frameworks out there to take a look at MutinyZero. Is that
yes? In that case, yes, it's probably the best thing. It's really the minimal set of the minimal APIs to write a publisher completely. There is a few helpers around completion stage because it's a very the API is it's kind of I don't know how to express it. I have a hate-love relationship with that API in the sense that I don't see anything wrong with it, but every time that I try to use it, I do something wrong. so there is something weird, but yeah. Typically MutinyZero provide a few helper methods to do this, like map, flat map, and things like that.
And it's really about making sure you respect the protocol, like giving you the just enough tools to make sure it will not break the Reactive Streams protocol. That's the big thing.
Yeah, because if you want to pass the TCK, there is a few tests that are named stochastic tests. Good luck with them. I didn't even know that word was existing before looking at it. Oh, that word exists. Okay.
It's beautiful.
So I know we talked about it before, having a blog about MutinyZero, about this integration stuff. Do we actually have that yet? I can't.
I'm pretty sure it's somewhere in my to-do list at some point.
Okay.
And I'm afraid the problem is me this time, but it's like if people have integration problems due to that transition to flow, perhaps it's my fault, and I'm sorry.
Okay. Awesome. Anyway, well, I think we're hitting the time, and I think we covered most of the stuff. Any other thing you want to share on Mutiny?
No, the only thing which we can recommend is that for early adopter people that really want to try, check the next alpha 5, so released on Wednesday if everything goes through, and the whole Maven ecosystem is fine at that date. They're still receiving errors, so it might be clunky, but let's see. And give us feedback. We know that things are likely to be broken, but that's the right time to just ping us, and we will try to fix it. There is in this Alpha 5, there will be the new dev UI too. I think we forget to mention that at the
Yeah.
I know it's merged.
Yeah.
It's
not
incomplete,
marked.
but merged.
I need to go look. But yeah.
So the new dev UI, which provide a much more interactive way, and it's both the old and the new one are available at the same time, at least for transition period. But yeah, it's much more modern in terms of how the front end is done. It's using web components, and the interaction with the backend is using WebSockets. So it's
wow, you're a full stack developer, Clement.
No, because I'm delegating all the CSS stuff to someone else. Because no. I've tried to get a picture on the left and text on the right, and I just gave it. So.
I know. You should ask Antonio Goncalves. He's very good at CSS.
Yeah, I know. Yeah, he's listening, and yes, he's a true front-end developer. He gave me some Angular code a few years ago that I'm still need to update once in a while. I have no idea what I'm doing.
Okay, but yeah, I do think it is but it's just not marked. That's why I didn't see it. So yes, that is true. Cool, awesome. Anyway, thank you all, Holly, Clement, and Julien, and yeah, we'll see you next week. Thank you.